Hello and good day to my lecturer and who's watched this video. Today I'm Luna. I would like to introduce you to my honor video presentation title, which is the chromatography in a food industry, the quality assurance of candy colorants. In this video, they would like to talk about the introduce, which is the introduction, the methodology, and the important, and they also talk about the result and analysis. You should stay tuned for the video. Before that, let me introduce the group member. Now, this is our group members. So first one, we have Nur Aimata Akma, and second one, we have Dayan Kukairunasa, and the last one is Ahmad Daniel. That's all, guys.
What is chromatography? Chromatography is one of the most widely used analytical technique in laboratories because it helps the scientists to separate, identify, and analyze different substances in a mixture. It works using two phases. The first one is the stationary phase, which remains fixed and can be a thin layer chromatography plate, which is the TLC plate, or chromatography paper. The second one is the mobile phase, which is a solvent that moves through the stationary phase. As the solvent moves upward, it carries the sample along the plate. Since each substance interacts differently with the stationary phase and the mobile phase, they travel at different speeds and become separated into individual spots. Next is principle of separation. The separation of substances in chromatography depends on their polarity. Polar compounds have a stronger attraction to the stationary phase, so they move more slowly along the chromatography plate. In contrast, less polar compounds have a stronger attraction to the mobile phase, allowing them to travel farther with the solvent because each compound has a different polarity. They separate into different positions on the plate. This allows scientists to distinguish and identify the different substances present in the mixture. So this is the formula for this topic, which is the retention factor. We can determine the retention factor by the distance traveled by the substance we divided with distance traveled by the solvent front. What is the retention factor importance is we can identify unknown compounds, compare with standard reference dyes, and also we can confirm the color additives used.
Moving on to experimental methodology, the first step is target analyte extraction. In our case, we need to isolate the active food dye from the complex candy shell matrix. We do this by dissolving the color coating in an optimal solvent system, which creates a concentrated liquid extract ready for testing. Next is precious sample spotting. Using a microcapillary tube, we carefully deposit a tiny volume of our extracted dye onto the origin line of the silica gel plate. It is crucial to keep the spot diameter as minimal as possible to prevent peak prodding and band overlap once the separation begins. The third step is chromatography development. We place the spotted plate vertically inside a sealed chamber that has been saturated with the mobile phase paper. As the solvent ascends the plate via capillary action, the separation occurs through differential migration. The components separate based on their relative polarity and how strongly they absorb to the stationary phase versus the mobile phase. Finally, the move to detection and visualization. Because candida contain distinct chromophores, we can visually evaluate the separated red, yellow, or blue band directly under ambient light. However, if we were analyzing colorless profile like paramecial compound, we would utilize a short-wave UV light chamber at 254 nm to reveal the spot via fluorescence sequencing. Now, let's look at how These basic analytical techniques scale up into a real-world manufacturing. In the food and beverage sector, DLC is a vital tool for regulatory compliance. It allows quality control technicians to run rapid screening to verify that only authorized synthetic colorants are present in the production line. It is also highly effective for contaminating monitoring, helping factories quickly catch any batch-to-batch impurity or unauthorized other trends before the commercial food product leave the facility. This simple lab process directly ensures that the food consumer is uniform, standardized, and completely safe.
Alright, next, let's take a look at the breakdown of the results for the chromatography of the M&M's candy. So for the red M&M's, we can spot one color, which is red, and the distance from the origin is 5.8 centimeter. For the blue one, we spot two color separations, which is light blue and a dark blue, with a distance of 3.5 and 5.6 each. And next for the green one, we can found two color separation, which is the yellow and blue, and 3.9 centimeter and 5.7 centimeter each for the distance. Next is yellow. We can spot only one color, which is yellow, and 4 centimeter from the origin. And next is orange. We can spot two colors, which is yellow and red, which is 3.9 and 5.8 from the distance. And last but not least, the brown M&Ms. We can spot three colors, which is yellow, red, and blue, with the distance from the origin 3.5, 5.6, and 6.5 centimeter from the origin each. We can calculate the RF values using the formula that was set by Dayang, which is the distance traveled by the substance divided by the distance traveled by the solvent front. So we can take yellow M&Ms as an example, which is the distance from the origin is 4.0 divided by the distance traveled by the solvent front is 8.0. So we got 0.5 for the RF values. So then the calculated RF values of the M&Ms were then compared with the RF values of a standard food dyes or reference industry reference, which is, as you can see here, I pull out the RF values for the synthetic food dye in the United States. So the closest one we got is 0.5 for the tartrazine in the United States. So if the RF value of the sample closely matches that of a standard dye, it indicates that the sample is likely contains the same dye. So a single spot with an RF value corresponding to the standard suggests a relatively pure substance, whereas the presence of two or more spots indicates that the sample contains a mixture of dyes rather than a single of the sample pure compound. And significant differences between the sampled and the standard RF values may also indicate the presence of impurities or differences in the experimental conditions. In conclusion, chromatography is an important analytical technique that helps maintain the safety and quality of everyday products by separating, identifying, and analyzing the chemical components. By comparing the RF values of samples with those of standard reference materials, manufacturers and quality control laboratories can verify the identity and purity of substances, detect impurities or contaminants, and ensure compliance with industry standards. In the case of food products such as M&M's, chromatography can be used to identify the food dyes present and confirm that they meet safety regulations. Therefore, chromatography plays a vital role in protecting consumer health and ensuring consistent product quality. That's all from us. Hope you like this video. Don't forget to like, share, and leave a comment. And thank you for watching. Bye!